Okay, welcome back. And in this video series, we are programming in ARM assembly. So let's just jump right back into the code. Okay, so in the last video, we were working on the first steps in getting our random number generator set up. But in order to get that going, I thought it would be good to read data from a file where that data was known. So I set up this file.dat that's just called, that just has A, B, C, D, E, F, G, H, I, J inside of it. And the goal was to just read 10 bytes out of that file. And I wanted it to be like known information so that when we're viewing it in the assembler, or rather when we're viewing the information inside of the debugger, we can tell definitely that we are reading the data out of that file, because you're not going to just randomly get A, B, C, D, E, F, G, H, I, J, showing up in memory if you're not reading that from some known location. Okay, so now that we're able to correctly open the file, read data out of it, and close it back out, let's go ahead and continue on. So let's go ahead and change the file now to dev urandom, and we don't actually need to read 10 bytes out of dev urandom, so we can change our buffer size, because if we're just going to be generating numbers that are like 0 to 100 or perhaps 0 to 1000, we only need just like, 1 byte will give you 0 to 255, 2 bytes, which is 16 bits, that'll get you all the way up to 65,500 and something. And 4 bytes will take you all the way to, like 4.2 billion if you're doing unsigned. And a game like this, it's really just 0 to 100 is all you need. So we will just read like, let's just read 2 bytes. That's really all we need. I'm not actually sure how the random, how that will show up in the register in terms of data. I don't know if we need to. Let's go ahead and write the changes and quit out. Let's rebuild our file, and I want to see what we can see in the debugger now that we've got everything switched over to /dev/urandom. Okay, so that's made. Now let's gdb random and just set a breakpoint at 1 and run. Okay, and let's go ahead and single step through until we're at the point where we want to see what kind of data we're getting. Okay, and now, so once we go past this point, we should have the data stored, and it should be at the memory address in register 1. So let's examine the decimal values. Let's examine the 4 decimal values that we read at that memory address, and it should just be, kind of random. So we got 1, 2, 3. So we got like 2 point, hang on, 1, 2, 3. So this one's like 289 million. This one looks like it's like 1.6 billion, 1.7 billion. And then this one is, looks like 459,000. Okay. So that's the data we got. So somehow we need to take this information and turn it into, let me think about this, and turn it into a number that's in the range. I guess we don't, obviously, if we're going to get values that are that large, we don't even need to read 4 bytes. Let me think about this. So let's continue through to the end of the program. Let's quit. And let me just come back in here. Let me change. Actually, that was only 2. I was only reading 2. So I guess I was looking at the 2 bytes that we read plus 2 additional. Let me change this to 1 and just kind of see. So let me go, and actually, let me think about this. Okay. So let's reassemble, let's relink, and let's rerun this in the debugger. And we'll do that again. And let's single step through till we read the data. Okay, and now that step reads the data. Actually, you know what? I should have looked at the memory address before and after. Okay, let's examine 1 byte of data at this address. Okay, so we have that value, whatever it is, 1,000,000 and something. So let's continue through to the end. Let's run this again. And let's single step through. And this time, before we do the service call, we will examine one data or 1 decimal value at this address. So we have that, which looks to me the same as it was before. So let's single step through and let's run that command again. Is that the same thing? I can't scroll up and see it. All right, continue, run again, single step. And then before, capture that. And then this time I'll highlight this so it's copied. Then we will single step forward and go again. Okay, no, it's a different number. Similar but different. So anyway, so it looks like we're able to read random data out of dev-urandom. Now we just need to figure out a way to convert that information into an integer that is confined within our limit of like 1 to 100. So let me think about that. And I'm going to go ahead and change this now back to a sort of, I'm going to make it so that it needs to be called from another program, basically. So that means we don't need any of this anymore. And technically, I guess we don't need that exit label, but we'll leave it there. So we do need to make an assumption about like what's going to be called and what's going to be returned. So we'll do the same thing here that we did with print s. We will push onto the stack all the registers that we're touching, which is register 0 through register 2, it looks like, plus register 7, plus, and then we'll put the link register onto the stack as well. Yep, just those. And then when we get to the exit portion, we will pop registers 0 through registers 2 off of the stack, and register 7 and the link register. And then we will branch exchange to LR. Okay. But there's one thing we need to do. One of these registers needs to, whichever register we're going to decide contains the random number, we need to make sure that register doesn't get popped off the stack, or we need to, for example, say that we're going to put that into R3 or R4 or something like that. So let's make that decision. So currently, let me think about this. Currently, the data that we're reading is being stored at the memory address of buffer. So we need to, before we leave, we need to recall buffer. Essentially, we need to recall recall value in buffer. So we need to load into a register of our choice. What register? Let's just say 0. So we'll load into register 0 the value, the data that's contained in register 1, or the value of whatever's in register 1. So that means that when we return, we do not want to pop R0 off the stack. We just want R1. So that means there's no point in pushing R0 onto the stack, because we're saying when you call this function, you're going to lose whatever's in 0. So we'll put that at the top of the file as like what we need to know about using this. So in R0, when this function returns, R0 will contain the random value, the random number. Now at this point, the random number that it's returning doesn't fall within our constraints, so maybe, but for now, let's just return that value back. Okay, let's write, let's quit, and let's update our makefile. And we're going to say we want to include random.o, and we want to compile, or rather assemble. And let's check our main file. So during this initialization section, this is where we'll get our secret value. So get random value. So we need to make a call, so branch and link to that rand function that we created, and when it returns, R0 will contain our random number. And we want to do that up here before we get into the loop, obviously, because we don't want the random number to keep resetting. That would be annoying. So that means we need to save the random number into a register that we're not going to touch down here, or we need to save it to a memory location and then recall it. But let's see if we have an unused register. So I'm going to do that. I'm just going to do search for R4, search for R5, which I can see is R6. Okay, since R6 isn't being used anywhere, I'm going to say move into R6, basically copy R0, because when we come back from rand, R0 will have the random number in it. It's going to be could be a very big random number. We need to figure out a way to constrain that. So let's go ahead and write that. Let's quit. Let's make. Do we have a... No. Oh, I typed move instead of MOV. Okay, write that, quit, remake. Okay, it's making correctly. Okay, so actually though, we're not loading it though. So we can get rid of secret now, or at least comment it out. So let's see, where are we calling secret at? We're calling it here. We're loading the secret number. So we don't want to do that anymore. Okay, yeah, we don't need to do this anymore. So let's just, for now, we'll comment that out. And instead of comparing R4 to R0, we'll compare R4 to R6, because R0 changes quite a few times, as you can see. But when we get back from rand, we make a copy of the random number and we store it in register 6, and then nothing else touches register 6 until we get down there. Okay, so let's try that. Make, and let me clear this out. Let's just kind of see what happens if we play the game. I think we don't have a range right now, so I don't have any idea what the number would be. Let's just say 50, 100, 200, 500, 10,000. Oh boy, 100,000, a million. Okay, let's try 500,000. 500, 1, 2, 3. Still too low. Oh wait, I meant to say 5 million. 5, 1, 2, 3, 1, 2, 3. Okay, so 5 million's too high. All right, let's try there. That's still too high. All right, let's try here. So it's somewhere between a million and 1.5 million. So let's try 1.25. Too low. So it's somewhere between 1.25 and 1.5. So let's try 1.37. It's too low. So it's somewhere between 1.37 and 1.5. So let's try 143. That's too high. So it's somewhere between 1.37, somewhere between 37 and 43 basically is what it boils down to. So let's try 140. That's still too high. So 138. Too low. 139. Too low. 140. So somewhere between 39 and 40. All right. Split the difference. Too high. 139. 250. Wait, 25 like that. Too low. Okay, so somewhere in that range. You can see the value of limiting this a bit more. What's halfway between there? 37. Too high. 33. Still too high. Okay, 139. 32. 139. 31. We'll get it. I'm determined. Wait, that was too high, so... Okay, so it's somewhere... We've got it narrowed down to a range of 100, I think. Yeah. So... 39.3... 50? Okay, so we got it narrowed down to a range of 50. 75, that's too low. So we've got it narrowed down to a range of 25. 1393083. Too high. We got it narrowed down to a range of 8. 1393080. Too low. Very close. It's only two more numbers it could possibly be. Too low. So there's only one more number it could possibly be. We got it. All right. Okay, so we're generating a random number, but the range is too big. Although, I don't know, that was kind of fun, actually. So what we need to do next is, I think what I will do is, instead of hard coding random.s to be restricted to a certain range, I'll say that when you call, before you call the rand function, you need to load your upper and low, you need to load your lower and upper limit into registers, so that when we come in here, we, instead of, saying it's always limited to 1 to 100, we'll say that, like for example, register 0 will be the lower bound and register 1 will be the upper bound. And then before we leave before we return, we will guarantee that your number is limited between those two values that you provided in those registers. I think that's the approach I'll take. So, all right, time's already gone by, so let's go ahead and close this out. Let's make vid 8, and I'll copy all those files over after I turn off the video. Thanks for watching, and I hope to see you in the next part.